All right. So hi everyone. Welcome and thank you for joining us today here for the Introduction to IOTA Tech Stack workshop. We are really excited to see you here. And here with us today, we have Gino, who will be conducting the workshop. All right. So over to you, Gino.
Yep. Thank you very much, Jai. I'm really happy to be here. I'm actually excited about it. And I want to say congratulations to all the participants of the hackathon. I mean, hackathon, it's a great way to connect with like minds, build fantastic stuff. Work in a team, make friends. Okay. So I have been part of some hackathons in the past. For example, I was part of the Chainlink hackathon that happened, I think like 3 years ago. It was a fantastic experience, an opportunity to build with teams, learn new stuff, break stuff. And, so for me, we are all winners, right? So even if you come out in the first position or you don't come out in any position, we are all winners. We've been given the opportunity to build stuff, and you never know what will happen after this, right? Because some of the hackathons have been opportunity to be part of in the past. Some of them led to projects that we are still working on. So I encourage everyone to give it your best, right? Have fun along the way and connect with people. It's really, really interesting to work with people from different cities or, different places. So my name is Gino, and I work with the developer experience team at IF. I've been given the privilege to present this session, and like you've heard, we are going to be talking about the IOTA technology and product stack. We have a lot to cover. I'm going to try to go at a low pace so we all get the best out of this session, right? Yeah. So just to give you an overview of what we are going to cover, we are going to look at introduction to IOTA and the journey. On this session, we'll briefly introduce IOTA and, how far we've come and from where we are coming from and all we've been doing to get to this stage. Then we'll also look into the tokenomics and the actors that play in the tokenomics should I say ecosystem or like the actors, okay? So then we will look at some resources where we look at some libraries, tools, and also documentation for building on IOTA. So I'll just give a brief, I'll just give a brief overview of IOTA, right? And the entities that are supporting it, right? So IOTA is an open source distributed ledger technology built to bring real-world applications on-chain, okay? It combines a permissionless public goods infrastructure and smart contracts for enterprise solutions and Web3 innovation. IOTA is led by the IOTA Foundation, which acts as the research and development lab working on the technology, and it is supported by the ecosystem entities in Switzerland and Abu Dhabi, right? The Tangle ecosystem and the IOTA ecosystem DLT Foundation. Yeah. So we've been doing this since 2015, iterating, coming up with good ideas, improving on what we have and looking for best ways to actually bring real world applications on chain. So IOTA Tech and Product Stack, let's look at the public network landscape. Okay. This is a diagram showing the journey so far, right? And if you look at the image, there's something that pops up, right? We always ask questions. For example, in 2021, Chrysalis network was launched, and there was a question by the task force, which is, I hope I'm on, like everybody can hear me and everything is going fine. Okay, I'll just assume everything is awesome. So the task force was tasked, there was a question raised, which was, how can we add programmability to our tech stack in general? Okay, and at that point, the conclusion was to create an L2 EVM chain, right? Which was launched, and that had to go through the development phase and the beta testing and deployment, right? And in 2014, the IOTA EVM was launched. Okay, so these questions are really important, just like how we got to this point, right? Another task force was set up after the IOTA EVM was launched. Another task force was set up, and the question was, how can we get programmability on L1 specifically? Okay, and reports, research was done, reports concluded, and a prototype was developed, right? And in 2015, IOTA Rebased was launched because of the question that was asked, that how can we get programmability on our L1? That, which means, how can we introduce smart contracts on the L1? You know, the EVM was a side chain, and but we wanted a technology where there was programmability on L1. So that was what led to the launch of IOTA Rebase after proper research, prototype testing, and all that. So that was how we got to launch the IOTA Rebase testnet, right? But this question is really important. And why do we want to bring programmability on L1, right? Programmability on L1 is crucial, right? Because it's where our base token resides, and all major use cases in the blockchain ecosystem, whether it's tokenization, digital identity, high frequency trading, they all require programmability on L1, right? So this programmability is essential for driving innovation and unlocking the full potential of decentralized applications. So that's like an answer to why we really wanted programmability on L1. So we'll look at the IOTA network landscape, right? And I'm assuming you know, or in case you don't know, it's made up of two networks. We have the IOTA EVM, which serves as the layer 2 side chain to the IOTA testnet, right? And it is built based on the EVM, the Ethereum virtual machine, right? And you can write smart contracts on this network using Solidity. And a lot of us are already used to Solidity. Solidity, or EVM, has like a very good ecosystem, right? Has a vibrant ecosystem. There are a lot of tools, there are a lot of resources, a lot of information about it, right? And the model that was used for EVM, it's the account model, right? Which is what all EVM-based chains are using. And the consensus protocol was proof of authority, right? So this is for the IOTA EVM L2 side chain. But right now, we've also improved, and we are moving to the having programmability on our L1, which is the IOTA testnet L1, right? So this is a highly scalable core layer based on the MOVEATHON, right? For the virtual machine that is used on our IOTA Testnet L1 is based on the Move VM, and you use the Move programming language to write smart contracts on this network, right? And the model, it's an object model. So this is something that's different from the EVM sidechain, right? It uses an object model ledger, and the consensus used here is delegated proof of stake. So that's the consensus we now use on IOTA Testnet L1, right? And so there are other great stuff that are on this network. For example, the concept of staking and getting rewards, right? Delegated proof of stake, where token holders get to stake or delegate their tokens to a particular validator. And at the end of the epoch, they get rewarded with some tokens. So IOTA L1 offers decentralization, higher throughput, and low latency, and building your smart contracts using the Move programming. For IOTA EVM, it provides development in Solidity and immediate access to the largest pool of builders. Like, that place is really, the community there is really big. So those are some of the distinctions between the two networks that we currently have. So let's look at the IOTA testnet, okay? And let's see some of the characteristics of the IOTA L1 testnet, okay? So this is a network or protocol that combines the best in-class innovation in the blockchain space, right? So building the basics for our IOTA testnet L1, right? A lot of research has gone into this, and we were able to bring in concepts from researching into the different blockchains. And some of the characteristics include sustainable tokenomics, right? There's fair token distribution and aligned incentives for all network participants. So if you're a network participant, either if you're a user or you are a token holder or you are a validator, there are incentives for everyone to be part of the network and secure the network. We also have a sustainable consensus mechanism, right? The delegated proof of stake consensus with up to 150 validators securing the network. There's also decentralized programmability. It's really exciting to bring programmability to L1, and smart contracts in Move enable flexible, secure, and composable dApp development. Okay. There's also composable ledger model. Like I said, for EVM, it is account-based model, and for IOTA Testnet L1, it is object-centric. It has an object-centric design, which offers high efficiency, seamless interoperability, and upgradability. There's also high performance, throughput beyond 50K TPS, transaction per second, and sub-second confirmation times for global adoption. So there's high performance, and also increased security because of the consensus mechanism and also the programming language that we are using. So let's take a look at the IOTA testnet tokenomics. This is really important. I mean, for every blockchain, tokenomics is like the foundation, right, of the economics of this system. So at launch of the IOTA testnet, 4.6 billion IOTA tokens are migrated from the previous ledger state, which is IOTA Stardust, into the current IOTA Move VM network. So, and we know that each IOTA token is divided into 1 billion nano, which is the smallest unit of an IOTA. We already know that the native assets for IOTA is called the IOTA token, right? So what are the purpose? What are the things that you can use the token for on the IOTA network, right? So you can use it for staking, which I've talked about that delegators or users, token holders, they're also called delegators. So they can stake their token and participate in the proof of stake consensus, where they delegate these tokens to validators who process the transaction, and at the end of the epoch, reward is being shared between these actors, right? And you can also use the IOTA token for gas fee, right? So you pay for transaction execution and storage using the IOTA token. It is also used for governance. You use IOTA tokens to participate in future votes on protocol upgrade. So I have a diagram here that shows what goes on in the tokenomics of IOTA. So for example, when a user stakes their token, or when the user carry out a transaction, right, they have to pay the gas fee using the IOTA token. And this gas fee is made up of, like, it's also called the computation fees, right? Users have to pay this fee. And a portion of this fee is burnt, right? And the staking reward, okay, let me use the scenario of a token holder wanting to stake. So you stake and you pay the gas fees, and there is a reward, right? And this reward is shared between the actors who are the users or the token holder and the delegators, right? So users also, you need to also pay for storage deposit, right, when carrying out transactions on the IOTA testnet, because don't worry, this fee is refundable. Like when the data is deleted, right, the storage deposit will be refunded to the user. Okay. So there is also something called fee burning model, where a portion of the transaction fee is burnt, and this reduces the token supply. Okay, and validators and delegators earn reward to maintain the supply balance, right? So let us look at the consensus in some more details, right? So IOTA Testnet, like I've said before, uses delegated proof of stake, where token holders stake their IOTA tokens to validators in exchange for rewards. For overview of this delegated proof of stake, this model allows token holders to give their tokens, or not like give, delegate their tokens to validators. And this also contributes to securing the network. And for validator selection, validators are chosen based on stakes delegated to them. So as a validator on the IOTA network, you need 2 million IOTA tokens to be part of the validator set. And you can get these tokens by, getting users to stake their tokens on your pool, right? And stakers can change their delegation to another validator. However, on staking during an epoch will earn no reward. So a staker is free to, after an epoch, choose another validator to contribute to the validator's staking pool. But you need to do that at the end of an epoch, because if you try to do it in the middle of an epoch, you will not earn any rewards. So validators manage pools that gather user tokens. There's also shared rewards where rewards are shared between validators and delegators. And a validator can set a max commission rate, right? So for a particular validator can say, I want 10% of the reward. I want 10% of whatever is staked by a user, right? So there's this shared reward process or model that happens where a validator can set his commission rate. And as a staker, if you think the commission rate is good for you, you can stake your tokens on that validator pool, right? So for economic model, it is performance focused. So efficient validators earn higher rewards, right? Because if you are not efficient as a validator, there is this model to make sure you don't get good rewards. So for you to get good rewards, you have to be efficient and you have to be, up and doing, right? So delegator influence, stakers can shift their support to encourage performance. I've talked about that. There's mutual benefit between validators and users, to secure the network. Now, for anyone that's interested in being a validator, there are some requirements that you need to meet, right? Okay, and they're simple standard that you just need to meet. So for example, a validator candidate must accrue at least 2 million IOTAs of stake before they can request to join the validator set. So as a validator, you need to be able to accrue 2 million IOTA tokens before you can come up as a validator on the network. And if an active validator stake falls below 1.5 million IOTA, the validator has 7 epoch of grace period to gain back those stake, before they are removed from the validator set. So these are very good measures or I'll say concepts for validators. So if your stake falls below 1.5, you still have 7 epochs to gain more stake before you are being removed, right? And I think one more thing is that if a validator stake now falls below 1 million, then that validator is removed from the network. So the IOTA consensus mechanism ensures low latency, high throughput, fast finality, it's energy efficient. I mean, the consensus mechanism is energy efficient compared to proof of work that is being used by EVM-based chains, and there's security and decentralization. So let us take a look at the gas and transaction fees. So there are 2 primary types of transactions on the IOTA network. We have the own object and the shared object transaction. I have slides where I'm going to differentiate between these, right? But we have these kinds of transactions, and these transaction types affect how gas is calculated, because shared objects often require more complex computation. If it's an own object, the gas that is required is low than when it's a shared object. Okay. So for gas components, so how do we calculate a computation fee? This is calculated by the number of computation units used, okay? And for storage deposit, this is required to store data on chain, and not forgetting that it is fully refundable when that data is deleted. I think these are very great concepts. For fee calculation, total gas fee is equal to computation unit times gas price plus the storage unit times storage price. There's also a formula for net fee, total gas fee minus the rebate for the data deletion. So for gas pricing, base fees applies to transactions involving owned objects. And like I told you, owned objects are less expensive, right? So minimum transaction size is equals to 1 million nano. An average size is 5 million nano. Yep. So Move overview, let's look at some concepts in Move, right? Because that's the programming language that we are using, to build applications on the network. So unlike account-based ledgers, IOTA Testnet revolves around objects. Everything we do on IOTA Testnet L1 right now is object-based, right? So, and the objects are the basic units of data storage, right? Then you have modules and package. So modules, it's where you have your logic. It acts as a container where the logic for your application is written. So for modules, it contains functions and logic of how the application works. And packages, for packages, it's a collection of modules. I'll just go through some attributes to try to differentiate or dive deep into these concepts, okay? So for attributes, I have definitions, purpose, characteristics, and example. So package, which is what you create when you want to build, when you want to write a smart contract on IOTA Testnet, right, L1. So for packages, like I've said, it's a collection of related modules with a unique package ID. Okay, and the purpose is to group and organize modules with related logics. The characteristics, it's immutable after deployment and can contain multiple modules, right? And an example is a package combining modules for inventory, matchmaking, and quest, right? So package is like a package is a collection of modules. So let's look at modules. So like I said, this is where your logic, it acts as a container for your logic, right? Where you write how you want, which is like the behavior. So in your modules, that's where you declare your functions and the logic inside those functions. And this is identified by package ID, right? Plus module name. And for the behavior, define behavior and manage object life cycle. I mean, for the purpose, it defines the behavior of your application, and it also manage objects life cycles. Like I've said before, the modules, it's where you declare your functions, right? But there's no state storage. And the way you pass arguments, you can pass an object to a function, for interaction. And an example would be a module managing character level up and combat logic. And also you can define a module that manages a combat logic. I mean, that's how it works in all systems, because inside your function, inside those functions are where you define these logics that when these functions are being called, they perform that logic that has been written into it. Then for objects, it's a data container without logic, identified by an object ID. The purpose for objects is to store and manage data, right? And it can be owned, shared, or immutable. And an example of this could be a digital avatar or item, right, that a user owns in the system, in the game. For example, maybe a sword, a rare kind of sword that is different from other kinds of sword on the system, right? Or the profile of a character, that can be an object. So object types, yes, I told you before that we have owned and shared object. So the fundamental units of storage on IOTA is the object, which consists of 3 fundamental different forms: owned objects, shared, and immutable objects. So let's look at them one after the other using the table described. So for owned object, it is controlled by a single address, right, or an object. So for example, on your wallet, maybe your token, you are the owner of your token, and you want to send that token to some other person. So it is controlled by a single address, right? And as part of its characteristics, only the owner can execute transactions on that object. And it does not require full validator consensus in transactions. And there's also an example there where a unique in-game NFT weapon or avatar that a player owns. So these are, from the name, owned objects. So it needs to be owned by one person and by an address. But for shared objects, it has general accessibility to multiple users, right? So maybe there are some items in, for example, a game scenario where multiple users need to own that item. So you make that item shared, right? Because multiple people are using it. So with characteristics, changes requires full validator consensus and enables collaborative transactions. And there's also an example there where a shared guild treasury or communal in-game asset that multiple players manage and update together. So those kinds of objects are shared. An immutable object cannot be modified after creation. They have fixed ownership. Ownership cannot be transferred. Ownership is static and cannot be transferred. Yes, represents permanent, unchangeable records. So any smart contract package is an immutable object by definition. Yeah, so for immutable objects, they cannot be changed, right? They cannot be changed, and the ownership is static and it cannot be transferred, right? So let us compare object-based virtual machines against Ethereum account-based EVM ledger, right? For object-based MOVEVM ledger, there's separation of concerns where data and logic are decoupled. So the data represents the object, and the logic, remember, it's defined in your modules and package, but they are decoupled, right? There's parallel processing. Independent objects allow simultaneous transaction processing, because consistently low fees. So one thing about object-based VM, there's low fees, right? And also high throughput. Why for account-based EVM ledger, there's unified structure, combines logic and data in one smart contract, which is something that's different from the MOVEVM-based ledger. There's scalability bottlenecks. Sequential transaction processing leads to network congestion. There's high gas fees, and the speed is also slower. So let us look at some tools, right? Some libraries and resources that as a developer you will need. So we have to answer this question: how can the IOTA Testnet help you, right? And we are going to look at programmability, the tokens, libraries for front-end, application building, and the dApp kit. So let me go to the next slide to explain some of these concepts. So tooling. So these are some of the tools that are in the tool suite, right, for L1 IOTA Testnet, right? We have the CLI, which is a command line interface. I think I have a slide for that, where I'll talk about that, but this is a comprehensive interface for interacting with the IOTA Testnet. So there's a tool called IOTA command line interface that enables you from your node to connect with the IOTA to communicate with the IOTA testnet. You can do a lot of stuff. You can use this CLI to carry out transactions, deploy smart contracts, do a lot of stuff. So the CLI enables developers to manage network operations, handle transactions, and identify functions from their own terminal. Yeah, I think that was the right word I wanted to use. I have a slide to show you some of the CLIs. Then we also have the Rust and TypeScript SDK. These are software development kits that provide libraries and tools in Rust and TypeScript, enabling integration with the IOTA Testnet for building apps and interacting with the network. So as a developer, you can build your Node.js project and use the TypeScript. Either if you're Node, you use TypeScript SDK, and if you prefer the Rust SDK tool, we also have it available. I'll jump to the Block Explorer. This is a web-based tool for visualizing and tracking transactions, blocks, and other on-chain activities on the IOTA network in real time. We all know the Block Explorer. We have this as a tool where you can go to monitor what's happening on the network. Then there's the dApp tool, the dApp development kit. So this is a toolkit providing developers with the necessary resources, libraries, and templates to efficiently build and deploy decentralized applications. So as members of this hackathon, these are some of the tools that you will need to use, right? And we have a documentation portal that you can go to find out details about all these tools. We also have the wallet, right? A browser extension wallet that you can plug into your web browser and be able to do a lot of stuff with the IOTA network. The EVM bridge is something that is not finalized, but it's coming soon, right? But this bridge facilitates IOTA interoperability between the IOTA Testnet network and the L2 EVM, enabling seamless transfer of IOTA tokens between these two networks. So for, like I said, we have the developer portal. The URL is docs.iota.org. Yeah, totally correct. And on this dev portal, you'll find all the resources that you need. So I always, this is like your first stop, right? When you want to learn about IOTA. So feel free to visit the developer portal. We have a lot of resources there and contents for you. So this is the CLI tool I was talking about. I said it's an interface that enables you to interact with the IOTA network and the Move programming language. So we have these different CLIs. For example, the client CLI is to interact with the IOTA network. We have a CLI for PTB, which are programmable transaction block. I'm going to also explain that a little. This is used to build and execute programmable transaction blocks, which are basically a concept that allows you to group multiple transactions into one transaction and execute them, once. I have a slide for that. Maybe I'll talk more on that later. Then we have the console CLI. We have the key to CLI, Move CLI, Validator CLI, and Genesis Ceremony CLI. And they all enable you to carry out different operations with the network. The Explorer, we've talked about this. This is where you can get real-time insights. Like you can view transaction, you can input an address to see transactions and everything about that address and network data. Then this also provides a transparent data, right? Because everything is in real time and you can track all the activities happening on the chain. This user-centric interface, you can navigate it effortlessly with intuitive search and filtering features. So this is the wallet, the browser extension wallet that you can use, to create your profile and, get tokens, send and receive tokens, right? Seamless browser expansion for your fingertip. So I think this is still about the wallet, where, like I said, you can set up profiles and accounts, create addresses, import private keys, And you can use this wallet to stake, right? To be part of from your wallet, you can delegate some of your tokens to a validator. So it enables you to be able to stake on the network. And you can use it to transfer asset and also monitor your assets. So this is the VS Code extension. As you need it for your VS Code to enable smooth development, right? It has language support, advanced debugging, it has seamless integration, and also documentation. So more details about the TypeScript SDK. Like I said, this tool helps you to build web applications and Node.js applications that interact with the IOTA network. So why will you need this? You can use it to write TypeScript apps on top of IOTA network, right? For those that are JavaScript fans, right? And you can use it to easily interact with the IOTA ledger, accounts, and smart contracts. It also has support for wallet operation, faucet interaction, NFT creation, and more. So I hope I'm still on point and everything is going on fine, right? So core features of the SDK: account management, transaction building and sending. It supports NFT and faucet requests and testnet integration, right? And the networks that you can use it to interact with are the IOTA Testnet, the IOTA DevNet, and local net, right? And these are some of the modules that you can use depending on what you want to do, right, with the network. So also is the ROS SDK. The same thing. Why use it? Ideal for performance critical low latency applications. It is memory safe and efficient. And some of its core features include send and receive IOTA tokens, create and manage wallets, build transactions with custom inputs and output. And the networks that it supports are same as that for the TypeScript SDK, which are the testnet, devnet, and local net. So the key component of this SDK is the IOTA client builder, right? This provides a simple and straightforward way of connecting to an IOTA network and having access to different available APIs. We also have the dApp kit, which is a set of React components, hooks, and utilities to help you build a dApp for the IOTA ecosystem, right? Its hooks and components provide an interface for querying data from the IOTA blockchain and connecting to the IOTA wallet. So some of its core features include query hooks to get information for your dApp needs, right? Automatic wallet state management, support for all IOTA wallets, pre-built React components, lower level hooks for custom components. And if you want to find out how to install it, I advise you to visit the docs.iota.org, which is our dev portal. We have all this information stored there for you. So let us look at some of the products in the the IOTA Trust framework, right? As you can see, 2 of them are still coming up, like they're work in progress, almost done, and will soon be launched. But the key ones here are the IOTA Identity and the IOTA Gas Station, right? So the identity is a W3C-based framework for management of decentralized identities, decentralized identifiers, right? DIDs, and verifiable credentials. So for those of you that are looking to build something around identity, this is a framework that you can play with, right? We have a lot of information about this on the docs. And then the IOTA Gas Station lowers the onboarding hurdle and abstract transaction fees for users. This is another very fantastic product that enables sponsored transaction. I'm going to talk about sponsored transaction in one of the slides, but It's a very fantastic tool that enable developers and organizations to take the burden of being able to acquire token for their users. To carry out transactions, you need wallet, you need tokens, you need to send tokens you need to pay gas fees for your transactions to be approved. But with this concept, maybe the owner of a project or a business or a developer that's building something for users can abstract that challenge from their users, so they can decide to pay these transaction fees for their users. And the IOTA gas station was built for such. So let's dive a little deeper into the identity framework, right? So just to summarize the identity framework, the IOTA identity is a decentralized framework that gives individuals full control over their digital identities. It removes the need for usernames and passwords, enabling secure, privacy-first interaction online through verifiable credentials, right? No more repeated forms or corporations data harvesting. Then for organizations, it simplifies GDPR compliance by shifting data ownership to users. Right? So companies can reduce risks, lower onboarding costs, and replace third-party logins like Google and Facebook authentication using the IOTA identity framework. And for devices, IOTA enables secure machine identities, allowing them to prove authenticity, interact autonomously, and log activities immutably, right? So some of the key capabilities of the IOTA identity framework: decentralized and self-sovereign identity framework, privacy-centric, verifiable credentials and trust anchors, scalable identity for people, organization, and teams. So this is like a user perspective of how the identity framework works. So for example, we have like a front end where we are building an application where, for example, a university can issue a digital certificate to a student, right? And this student can share this certificate with anybody, and that person or entity would be able to verify the certificate. So this is an example of how you can use an identity framework to build a university application that enables a university to issue a certificate, and also anybody can verify that certificate. So when this front end interacts with the identity framework that is built on the IOTA testnet. So more details into the IOTA gas station, right? So why was this created? What does it do? So we have the concept of sponsored transaction. I've talked about it a little. Sponsored transactions allow one account to pay the gas fee for another user's transaction, right? This is a very fantastic concept. So this means users can interact with dApps without needing to hold IOTA tokens. I mean, that's fantastic, like removing a common barrier to entry. So this is a concept that, like I've explained before, enables developers, organizations, or anybody building projects to take the burden of gas fees and all that off their users. For time's sake, I'll just, not go into more details. So the components of the gas station, it has an in-memory data store used for managing session data, transaction queues, and distributed state management, ensuring high performance and scalability. Then the core server is responsible for handling sponsorship requests, managing gas pools, and interacting with the IOTA network to process transaction. And there is a key management service. The KMS which is key management service, offers enhanced security by managing cryptographic keys separately, ensuring secure signing of transactions. So programmable transaction block, this is the concept I was explaining that enables you to batch up multiple operations into a single atomic transaction, right? So an overview would be, for example, you can combine up to 1,024 commands in one operation, in one transaction, right? So what happens, if you go on the website, you'll see how this PTB works, okay? You group multiple commands into a particular transaction. And this is awesome because it makes the transaction cheaper. So imagine you, maybe in EVM-based kind of chain, you do transactions one at a time, right? And imagine you can group 5 or 10, or even up to 1,000 of these transactions, of these individual transactions into one, and send it as a single transaction. I mean, this reduces cost effectively. So, and when you group these transactions, they are executed sequentially. So results from one of the transaction command can feed into the next, right? And it has this concept of if one transaction fails, every other transaction fails, right? So it has for key features, low fees, fewer limitations, no complex loops. Then for usage scenarios, handles multiple object updates in a single shot, which I've been explaining. Chain logic, pass commands output to subsequent commands. So if you have like 5, and if there's an output from the first transaction, it will be passed to the second transaction. And it's really cheaper, right, compared to executing multiple individual transactions. I'll just skip this for now, and because we've spent about 50 minutes. So here are some of the resources that you will need for this hackathon. So we have some resources for developers, which is the IOTA docs, IOTA network endpoints, IOTA CLI, IOTA RPC, Rust SDK, IOTA TypeScript, IOTA dApp Kit, the VS Code extension, IOTA Identity, and IOTA Gas Station. So these are all on the developer portal. Feel free to stop there and research more about them to see how you can use them for your projects. Then for products for end users, the Explorer is there and the browser. Then third-party products for end users, I guess we have the IOTA Scan browser and the nightly wallet. So that is it from me. I will hand over to Sanj. My God, I hope everything is going great. I'm also going, okay, yeah. I wanted to check the chat to see if we have some questions, but over to you, Sanj.
All right, thank you, Gino, for taking your time today to actually lead us through the session. Really appreciate the insights and the walkthrough of the IOTA Tech Stack. Right. So right now in the chat, there are a couple of questions from some of the participants here. Maybe you could address some of the questions. Right now, I think Victor has a question there.
Victor, any React Native support? Yes. Yes, it supports React Natives. The IOTA TypeScript SDK supports React Native. Yeah. So you can build React Native's app, mobile apps or something on the IOTA network. Yep. Then trying to look for some of the Heidi and Victor. Could you please elaborate on your questions? Gino may be able to address, okay. IOTA NPM package is compatible with React Native framework. Yes. Yes, they are. They are compatible with React frameworks, please. Any mainnet? Mainnet will be released, I'll say in a few weeks from now. Yes, that's all I can say about it. Yeah, mainnet will be released in a few weeks from now. But feel free to work with the testnet, right, for now during this hackathon. And so you can migrate your application to work with mainnet when it is released. Yep, I think those are some of the questions on the chat, right? Please don't forget we have a dedicated Discord server for this hackathon. Feel free to ask questions over there. We have mentors and people that will be willing to provide answers. Yep.
All right, thank you very much, Gino. Also for everyone to take note, we do have a dedicated AMA session on April 21st. So make sure to submit your questions and also ask any questions, do attend the session so that you can ask more follow-up questions to any of the explanations that the mentors provide from there on. Okay, then I think that actually wraps up everything for today. Thank you once again, Gino, for taking your time to go through this session today.
Thank you for
Okay,
having me.
thank you, everyone. Bye-bye.
Yeah, wishing everyone a great experience in the hackathon. Yeah, cheers. Bye.